Hi guys, thank you for coming to this presentation. Today we're going to talk about graphs and like what we can do with graphs and like how they could be useful. Um, our agenda for today, first talk about the theory and what Neo4j is. Then we will do some because I want to make a presentation more practical. So we're going to design a data model, review Northwind data model. It's one of the sample databases which was available for years. And after that, I will quickly show you how you can create your own Neo4j database, and then how you can deploy a model and do some Cypher querying. Cypher is a language that Neo4j uses to query data. So let's kick started. So graph theory started in the middle of 18th century by Leonard Euler, a famous Russian or German mathematician. So we are still fighting. Was he a Russian or German? But anyway, so he lived in Königsberg. It's Kaliningrad nowadays. And he wanted to solve an interesting problem. So in Königsberg, you have a river and you had a few bridges. And Euler wanted to use a paper and draw lines through every single bridge without crossing it twice. And that's how we came to an idea. Okay, so let's do some mathematical representation of this model, and he invented graphs. So let's briefly talk about what graphs are. So basically, graph is a simple concept. You have edges, you have nodes, which is a point, and the points have connections between them. So points usually known as vertices or nodes, and edges is just connection. So in earlier model, you had like points on the map, and bridge was an edge. There are two types of graphs. There are directional graphs, which means if you have point A and B, you can always go from point, let's say, A to B, but you cannot go back. And in unidirectional graphs, you can go back and forth. So let's see how like this simple theory could be used in our world nowadays. So graphs are used in multiple industries. Like logistics uses a lot if you want to do like a transportation or like some like Google Maps, for example, you want to like create a route, you'll use graphs. In finance, we use graphs a lot when you do. So, for example, you do like trade investigation or even like crime investigation. If you see, okay, where money came from, and if it's like a legit thing. In cryptocurrency, graphs are used quite heavily for crime investigations, for example. In network in IT operations, it's used so used in, for example, if you have a network, enterprise network, you want to see, okay, how data is flowing through your network, what are firewall rules, etc. For example, I personally worked in a project where we built a model to predict potential data leakage and like data flows in network. So you have like enterprise network, and you can predict, okay, if there's a configuration mistake somewhere which we don't know. And last but not least, nowadays generative AI use graphs quite a lot. For example, if you use tools like Longchain, it has like native support for Neo4j. And the idea here is you have graph, and your Gen AI needs some data, some quality data, and your Neo4j, since it has information and relations between different informations, you can feed it into your Gen AI to produce better results. So why graph databases? Because we've been using relational databases for many years. But graph databases solve for one particular need. When you have hierarchical data, relational databases are pretty bad and pretty slow. And that's where graphs win. For example, if you want to represent a route, let's say a Bangkok roadmap. Of course, you can do it in a relational database, but if you try to build a route, it will be a very heavy query, which is hard to debug, and probably it will take ages to come up with the result. And graphs can help to solve it. Also, graphs could be helpful when you try to find some hidden information inside the relationship. For example, you have your enterprise network, you load this data to a graph and start analyzing the graph, and you can at some point find out, oh, okay, we have like a subnet which no one uses at the moment. It's still there, but we never built like firewall rules, for example. Now Neo4j come to our play. Unfortunately, in graph space, there are not that many database vendors. Yes, like the theory about it and the technology was around for a while, but it's a very niche product. And Neo4j is probably one of the best players, at least from what I personally tried. First of all, it's natively designed to work with graphs, and it's graph database. It's not like a MongoDB where you have documents, but they add more and more features on top of it. No, they precisely work on graphs. It's very, it has a good scalability, and it's a high performance database. It's fully ACID compliant, which is not the case for some non-relational, NoSQL databases. And it's open source. It's under GPL 3, and there's also a cloud version called Aurora. And in my opinion, if you want to quickly try or learn Neo4j, probably Aurora could be a good thing for you, because you can go to the cloud, create a free version of the database, load your data, and play around. Let's take a look what is a data model inside Neo4j. So in Neo4j, there are 4 major data elements: nodes, nodes, relations, labels, and properties. So node is actually data which is persisted in your database. For example, here I have 4 nodes, Bob, and like some of them like people, some of them are stations in London Tube. Relations are the links between those nodes. For example, here I have walk, ride, walk. Labels, there are different types of nodes. For example, in this system, we deal with people and with tube stations. So personal station, those are the labels. It's like a common tag for a particular subset of nodes, and each node could have multiple tags. And properties. In Neo4j, you can add additional metadata to nodes or to relations. That's how you can model very complex systems. For example, here okay, we have a person Bob who lives near Bond Street, and if you want to go to Alice, he should walk for half a mile. Okay, so I want to make this presentation kind of practical, because when I learned Neo4j for myself, first I struggled with Cypher. And I personally like learning by example. That's why I took existing Northwind data model, which came originally from Microsoft, and it was developed for SQL Server. And then I took similar model in Neo4j and start to run queries. And that's why I want to show you how a particular SQL query, starting from simple queries, more complicated ones, will translate into Cypher queries. So that's our model in SQL. So you can see we have a total joins, and that's how this model looks in graph. So basically, we have 5 labels here. So we have customers, orders, categories, suppliers, and products. And between those nodes, there are different type of connections. So in our case, customer purchases stuff. So customer creates orders, and which order contains of products. So that's how we link everything to each other. And instead of having all this heavy table implementations as in relational database, when you load Northwind into graph, it will look something like that. So you have several customers. For example, here our customer created like 5-7 orders, and then from each order we can see, okay, what products he purchased and who was the suppliers. Okay, so next I'll just briefly show you how you can set up a new database. You usually go to Neo4j and you create your account. Then it will ask you to create a new database. The process is simple. You just click create, and it will ask you, okay, you want to like paid version or free version. You choose free version, and after like a few minutes, you have your instance up and running. Then you need to restore the database. Northwind database, it's one of the samples which comes from Neo4j. There is a GitHub account where you can download like other samples. To restore, it's very simple. You just go to this web UI, click backup and restore, drag and drop your file, and after around like 10 minutes, since it's a free version, you will have your database. And that's how your admin panel or like a query environment looks like. Here you can see all possible nodes and all possible relations between nodes, and even the properties which you used either on relations or nodes. And then you have a query console. Okay, so let's start talking about Cypher. Cypher is a query language. There are like 2 or 3 different graph query languages available at the moment. And Cypher, if I'm not mistaken, was the first one, and it's the most popular one. For example, if you decide to go with AWS and use AWS Neptune, they will provide, like Cypher will be one of the options to use as a query language. And here it's a basic syntax. So you remember we have like nodes, labels, relationships, and attributes, and that's how you do. So nodes always in the parentheses, like here, for example, categories like our label. So this is some sort of syntax which we use. And the important thing when you define relations, you can query based on directional relations or like undirectional relations. So here at the top, you can see the difference. And from my experience, like from practical experience, try to use direction relationships as much as possible, because when you have like unidirectional relations, they're a bit slow, especially if you have like a large graph, it will slow you down. So let's compare SQL and Cypher. So that's a simple query, get all customers in SQL, simple. And on Cypher, so we use match statement. So match is it's a keyword, it's a Cypher clause similar to select. Then you say, okay, I want all nodes of label customer, and you always have to return something. So when you run it, it looks like this. When you use Neo4j environment, you can have multiple views. I found a graph, when you try to understand like how your graph looks like how your data is shaped, it's better to use graph representation, but try to limit the amount of nodes you draw, because if you can try to visualize like a crazy big graph, but then it's unreadable. You can also use like table representation. So table representation, it helps you to develop applications. So I'll show you next. Again, start simple. Again, I want to show customers, but this time I want to order them and get on it top 25. Select. Okay, in Cypher, we use order by syntax, similar to SQL, and limit. That's the way how you can do like pagination or limit the amount of data of your data output. Again, if you play around with visual graph representation, it's always helpful to use limit. Now, just to prove, I show you how the table representation looks like. So here, you see the underlying data structures which you will get if you query Cypher from like Python or from any other programming language. And yeah, so here you kind of prepare your query output to use in the application. Let's go next. get orders from 1997. Yes, Northwind is old. It was popular till 2000, I think. Okay, simple SQL and match. So here we introduced where clause, which works similar to SQL. The important concept which I want to highlight here is this syntax. Because in SQL you have a field and it has a data type. Then you have functions which you can apply to your data and like year. In Cypher, you deal with objects. Date time, it's an object, and that's why in Cypher you can have like this object notation. So year is a field. So it's more like a object-oriented concept way of doing things. Okay, next one, get all placed orders. Simple query. There is not a difference between SQL and the Cypher. SQL understands date literals, so you can put your constants like this. In Cypher, since you deal with objects, date is an object. That's why you have to use this like a date constructor. So you say, okay, this is my date, which is a string. Let's parse it and create a date object, and then execute query. Okay, so next, create reports for all orders. Now we start to use joins. Here we join orders and customers and try to find the information. In Cypher, we don't have joins. We use relationships between nodes. So here we say, okay, we have customer, and we know that customer, there's a purchased relationship between customers and orders. And we just say, hey, Neo4j, please give us a subgraph of our customers and all linked orders. And then we apply where clause, okay, for this year, and then return P. This is like a strange syntax. So when you do match clause, you always have to return something. And if you write like a P equals and then your expression, it's like a shortcut to say, okay, I want to get all output from this expression. If you don't use this annotation, you have to provide, okay, I want to do like C or. So it's like a shortcut. Okay, now it's more interesting. So we are going to get a report of customers. So now we have select. We don't want to return everything. We want to return only particular fields. Here, Cypher is similar to SQL. You just provide in your output, instead of saying return P, return everything, you just say, okay, please give me only a particular subset of information I want. Okay, let's see how we can use aggregation. Okay, so here we show a report. We want to see how many cities we have. So we want to see like how many customers we have for each city, and group by SQL query translates into relatively simple Cypher. So you just you query your subgraph, and then you say, okay, I want to get a city, but then I use aggregation function. So what happens in this case, Neo4j just does group by city and gives you total number of nodes which is connected to the city. Okay. And now we're getting a more complicated query where we're trying to use having. So having by filter. So first we get information, we calculate the total quantity sold for each product, and after that we want to apply filter to the total sum. So as you can see, like SQL queries are getting bigger and bigger. In Cypher, it looks a bit shorter. So let me explain. First of all, we say, hey, Neo4j, give me a subgraph of all orders and products. And then we apply an aggregation. So when Neo4j executes Cypher, it works similar to MongoDB aggregation framework. You get the data, first you get your subgraph. And then this statement, it applies data transformation to the previous step. So here you say, okay, from the subgraph, we want to get a product name, and then we want to calculate the total quantity of products sold. After this stage, your current query state will give you you'll have only product name and quantity fields, and everything else is just hidden from you. So on the third line, you apply the filter. So that's where it's like a having by equivalent in Cypher, and everything else is just recorded by. So here we use this clause. As I say, this is some sort of aggregation framework for Neo4j, where you can transform the output of the previous steps. And usually it hides. So for example, if you have some data on the first step, then use this. The data from the first step is hidden, and only new fields are available for you to use on the next steps. So you can use a wildcard character to get everything. And there are like some aggregation function available in Neo4j. So the next query. So in this query, we are doing a similar thing, but we try to mix where and having. So what happens in SQL? So first you apply a where clause, and you filter out some data, and then you apply group by operation, and then run the second filter. So in Cypher, it looks almost the same. So we just have two where clauses, and that's it. Okay, so here it's a more complicated query where you have multiple joins, and we want to do some calculations inside. So we do some calculations and then do grouping based on those calculations. So in Cypher, again, it looks a bit shorter because we don't use join. We don't do like a join statements. We just say, okay, this is our subgraph, and then we apply calculations on the subgraph. Okay, so it was a brief introduction into how to query data. So now let's go. Let's take a look to create, update, delete statements, how it works. So that's a standard SQL insert statement. And so in Cypher, there are two insert statements. First one is create. So create is it's a simple insert, and it doesn't check if object exists. So for example, if I implement this insert 10 times, I'll get 10 nodes with the same data. On the other hand, if you want to have an upsert, and for example, here I want to have myself as a customer inserted only once in the database, I have to use merge instead of create. And when I do merge, I have to provide some, in curly braces, you see this like customer ID equals Ilya1. So this is your filter. So it's like a primary key in SQL. So now if I run this 5 times, I will have only one object. So multiple updates are getting more interesting. So here I'm trying to add a new order, which means I have to do like several insert statements, and usually in SQL we use transactions for that. So in Cypher, it works in a more declarative way. So when you write one query, it may have multiple match and merge statements. So inside one query, you can run multiple absurd operations, but it all run as one transaction. So here I say, okay, find the customer Ilya, then find the product tofu, then let's create an order with order ID 1990. If it doesn't exist, if it exists, fine, just update the order date. And then the fourth line says, okay, now we want to connect customer to this new order. And the last, we say, okay, customer Ilya purchased order, which we created before. And then now we have to link our order to the product. And here is the last merge statement. This is our link. And in Cypher, since you can apply attributes to edges, to nodes, and to relationships, I provide some metadata to the link, the relations between orders and products. This is like one way how you eliminate those connection tables, because in relational database you usually have this like order details table where you link together orders and products. Here in Cypher, just put all this metadata inside into the relationship itself. And if you run this query, and if you use return statement from any like CRUD operation, you can immediately visualize the output. So that's our new models. So for update, we just use merge. And so this update, if you use default data dump from Neo4j, your order date will be a string. And this is how you do update all in Cypher. So you just convert data type of order date from string to date. So again, if you want to update your phone number, merge statement. So here we do some join and update. I want to double the quantity of my products. And in Cypher, again, it all runs in one transaction. You just say, hey, please give me my subgraph. And then you just use set keyword to update quantity. And that's it. It all runs in one transaction. So now delete. Again, in SQL, since we have like multiple tables with different relations, we have to use transactions and we have to follow a particular order. So first we delete from order details, then from orders, and then we remove customer. In Cypher, it's simpler. You say, okay, give me my subgraph, and then use detach delete operation to remove all the nodes and edges and relations. And I think that's it. Thank you. So it was a short introduction into SQL versus Neo4j. Hopefully you will try it a bit. Thank you.
Nodes pointed to each other and
yes, you can, because if you go like into more advanced concepts, you can try a pass. So for example, you can say, okay, those are like my two nodes, and I know that there are like 10, 20, 40 hops between them. So you can run a query saying, okay, how I can get from node A to node B, and please give me all the like shortest path or like all different paths. And usually When you run this query, you say how many hops you may have, and if you have too many of them, then you have timeout query. And I think Neo4j will also raise you an exception if there's like a cycle dependency like during this computation. And yeah, again, from my experience, depending on the server you use, up to 20 hops it can handle. Okay, more than 20 hops it will be challenging.
You run models on labeled graphs on Cypher.
What do you mean models?
Does mean let's say certain relationships are not as written from
Mm-hmm.
the map. So you want to run this to try to predict.
Oh yes. So yes, so it's not in Cypher. Neo4j has an ML library, so there's a set of functions which can help you to build those ML models. For example, to predict like fraud on fraud, and yeah, you can run it in Neo4j. It's like Cypher, it's like Cypher with some functions. Mm-hmm. Yes.
Yeah. Thank you for the talk. I understood some of it, but with the Cypher language, is it possible to transpile it for use on an RDBMS?
No, it's only for Neo4j. Oh, it's only for graph database, because on RDBMS, when you represent the graph, you usually have this like join tables, like order details, but you will have those tables and you have multiple joins between them. In SQL Server, and probably, if I'm not mistaken, Postgres, they have syntactic sugar to support three likely structures. For example, if you have like a organization chart, like managers and like colleagues, whatever. So you can use like I think it's called like CT expression, where you can query those type of relationships, but it's more like a top-down directory, like top-down tree, not like a graph where you have like a link to anything.
And also, what is the origin of the name Neo4j? Is there Java in it somewhere?
I know it's used Java under the hood, but I don't know like why it's Neo4j. But it's written in Java.
I see.
Huh.
Yeah, is there some sort of abstraction that developers usually work with when they interface with Neo4j, or do they at least try to end up writing Cypher, because there's a lot of object oriented
Yeah. So
objects like Neo4j say.
yes. So yeah, that's how it works. So you usually Neo4j, when you design a system for Neo4j, you have to come with questions, because you cannot build like abstract graph, because it will be not good from performance point of view if you just put everything like it's like a giant thing. So usually when you design a system based on that, you say, okay, this is like my top 5 questions which I want to answer. Let's try to design my data model based on those like 5 questions, and then then use it. But it's mostly objects. So when you use it in Python, you have noticed it's an object with fields with your properties. You save it, and then you query it. Yeah. And you get back objects as well. Thank you.